Thank you very much, Antonin, for this very inspiring talk, which stressed this importance of multimodality and frames analysis. That's very important indeed. So, as we did for the previous session, we will gather all the questions after the two first talks. So I'm inviting Houda to come here, and I will present her. So Houda is a postdoctoral fellow at this University of Liège, and also the KU Leuven. She holds an interdisciplinary PhD in computer science and art history, which is quite rare. Her research interests around the usability of digital interfaces in art history and humanistic research. She also has background in artificial intelligence and explainable artificial intelligence, that's all explainable, and approaches digital research with a critical social lens. Houda is currently part of the Imaginology projects together with Maria Giulia and contributes to teaching in human-computer interaction and information visualization at the KU Leuven. Thank you, Houda.
Thank you for the introduction. All right. Yeah, so I think that was quite a good introduction. Then I will just step right into it. It's the end of the day, and we're all very tired. I admit that I'm getting a bit a bit less energetic than I would have liked to be for this talk. So I will try to keep this a bit light, and maybe not to talk for longer than I need to, which we can all do sometimes. So this talk is titled Steps Towards a Grammar of Forms in Visual Art as Input for Computer Vision Algorithms. And Maria Giulia already introduced the project in the morning. So as you may remember, the project that we're working on is about finding a genealogy of forms using computer vision, using image analysis tools. So I will complete a bit of that introduction. I want to talk a bit about the literature in computer vision, what it can do, what it has done, how it can help for formal art analysis. I'm going to talk about our case study, which is the project, and then end on some limitations if we have time. If not, just maybe introduce some ideas for future discussion or future reflection. So let's start with the literature. I'm very aware that throughout the day there was a lot of references to things that I was planning to talk about, or to some parts of the literature. So I'm happy to already have be in a discussion where everyone is a bit primed, has seen other examples. And as is often the case in this kind of environment, I am aware that we all have very different understanding, backgrounds, familiarity with technical concepts or with humanist concept or art history frameworks. So if there is something that you know already, that you're familiar with, that we can also contribute to in the discussion, that is great. But some of the things you may already know, and I don't think that that's not an issue. That's maybe part of the discussion as well. So computer vision, what is it basically? It's a set of tools, a set of techniques to analyze images, right? And that's a way to analyze images not through like a framework, a human or conceptual framework. This is a way that we're going to cut up the images, understand it. It's basically a way to feed a bunch of images, millions, thousands, different frames for different models of images, try to teach something and try to see what we can do with the outcome. Sometimes the outcome is interesting. Sometimes we don't know what to make of it. That can also be interesting conceptually, but maybe not very practical. So there's a few different categories of computer vision algorithms, some that have to do with face detection, some that have to do with recognizing whole objects, with, for example, in C, constructing a 3D environments from, let's say, a set of images, or a stereo matching algorithm, which also has to do with recreating 3D models. Historically, it has evolved in different ways. I'm mostly talking about this because I think it's very important to critically engage with computer vision as a tool that is very powerful, but that is extremely limited and extremely limiting, because it's a black box. It's something that was developed for very specific applications. So computer vision is mostly used in medical applications and in military applications. So my argument here, or my question here, is how well does that translate to understanding art, to understanding humanist material? The question is of course depends on who you ask. So there are two main issues that appear when we talk about that. The first is how accurate these algorithms will be. So if we train algorithms on medical imaging to recognize, I don't know, we show it a million images of healthy brains and some images of brains that don't look like that, then it's a very good thing that it can recognize them. But these are very structured. Brains have the same structure. The medical images look a bit the same. So we have black and then a bit of gray and white. We have this opacity and transparency that can play. Military applications are a whole set of a whole can of worms, but they're also quite technical, quite similar images. So if it's let's say visual images from a top, from a drone or from a helicopter, we are talking about landscape, some objects that have specific forms that can be recognized. So the first is a question of accuracy, and the second is a question of bias. And the bias is a very big issue in computer vision algorithms and in machine learning in general. And that is because, well, we have to train these algorithms on something. And in the case of the internet, that something is not necessarily high quality images. For sure, it's not going to be, you know, paintings or visual art. It's mostly pictures that we post on our Facebooks, or pictures that, you know, have been input into a database, or pictures that have been posted without the consent of the people that who they belong to. These data sets therefore have a lot of bias into them. They have a lot of of stereotypes into them. They show very clearly some specific aspects of some communities, of some groups, and they are, you know, very hesitant or very ignorant about other large populations. So the issue then becomes, if we want to use these tools as a way to conduct art history research or to conduct research in general, then we really need to understand basically what they can and cannot do, and what we ask from them. Is it realistic to ask specific questions from them? Is that helping us? And how can we orchestrate this research in a way that we are not unaware of some of these biases, and that we know how to handle them, how to address them, and how to conceptually understand the results that they give us. So this is an image of, it's very unrelated, but I like to use this metaphor. It's the image of light as either a particle or a wave. My understanding of a lot of what we do with machine learning algorithms, especially in the humanities, is that we're trying to organize concepts that are very blurry, that are very kind of messy, that are difficult to understand, because life is messy and blurry and difficult to understand, and so art therefore has to be. And with language, already this translation from images to language, we already need to put them in some boxes. We need to delineate and categorize and try to put words onto things, and try to create some structure out of that. In order to feed anything at all into a computer, we need to go beyond that, because computers understand structure, but computers need structure to be extremely specific, extremely technical, extremely numerical. Even concepts, categories that we can, you know, agree on and understand and talk about and read about are still going to be miles further than what a computer will understand, because it's not in, let's say, a CSV file, it's not in an Excel sheet, it cannot fit into a database, or it's going to be highly messy. So we can easily imagine, once we translate these concepts, a series of not categories, but of very, maybe 2 or 3 tiny little boxes that we need to transform and reduce all of this breadth of information in order to fit into algorithms. And another way that I also like to think about this, so this is the same kind of concept of image, traversing a slit and then appearing as a slit of light. In each of these moments that we have a slit, and so that we force things into categories, we also create a breadth of new question, a breadth of new interrogations, of new research and new scholarship about how did we categorize that? Does that make sense? How did we choose that data? Does that make sense? So we are feeding into this loop of creating categories, forcing things into tiny boxes where they don't fit, and through that also creating new knowledge, new scholarships, new reflective conceptual discussions about the process that we are partaking in. So this leads to the 2 main questions that I'm really just thinking about as we are working on this project, and as I start this work on computer vision in visual art. First of all, how useful is computer vision in this field? And how can we critically engage with it in order to properly use it and know how to wield it as a tool for art history scholarship? So in this part, I think, again, these are some of the examples that Maria Giulia already showed this morning, so I don't want to get into them too much, but formal art analysis in a way is perhaps one of the things that we could do, or we can get closer to doing with computer vision, because we're not looking at the context or the social dynamics of the artists, or all of the things that are not exactly in the image. So that is a thing that is helpful. So a lot of there's a few works in the literature that do manage to get very interesting results. For instance, this is a work where computer vision is used to find similarity in postures, and therefore the paper is called, this is very tiny, I'm seeing that now, so you can barely see the references, but the paper is called Linking Art Through Human Poses. And so they have a big, I think, data set, and they do image pose matching, I think, with OpenPose, to find similarity in art where it would have been a bit tedious to find it by hand. So there's interesting work in the literature. In a different way, we can talk about icon class as well, where instead of using computer vision, then the idea is just to really describe as specifically as possible. And that also brings up about the topic of poses. In this case, there is a category that is a subcategory of subcategory at the 5th or 6th level. We are in 31A 2522, and the title is Hands Folded. And if we click on this category, then we see the images that have this posture of folded hands. And we can use that as well to link images that have a similarity. This is another, I think, interesting project. That probably will not work. It's working. So that is a work of art and research by Memo Acton, who created a system where you can manipulate an image, and there's a camera that looks at it, and that model is either fed just water images, just the sea. So it tries to create similar images, but because it only knows the sea, then it will create an infinity of images of the sea that look like the structure we're making. If we feed it, let's say, fire, I think, yeah, then again, whatever we do, at least in the visual sense, will appear as an image of fire or of flowers. It's really beautiful. And up here the flowers are, I think, quite nice. And in this case, it's not looking for similarity, but creating similarity, because we're basing ourselves on, or the authors base themselves on, not style transfer, because that is also something else, but creating this kind of visual structure based on being fed a specific type of images. So yeah, I think that's quite interesting work. Oh, I lost. And so yeah, basically that's kind of, you know, a few different inspirations and thoughts and discussions that are going on throughout this project. These are some of the research goals that were already presented this morning, but I can talk about some of the initial results. So in order to find this posture and these similarities, what we had to do basically was to find images that come from paintings, and also images that come from photography, and particularly fashion photography, because that's what we're interested in, right? Like the genealogy or the history of these forms throughout time. So what we've done was to go through or to collect two big data sets. First data set about fashion photography, and this also goes back to the whole discussion of, you know, data set creation and how much they affect the result, and that often it's a decision because of practical things. So this was the easiest website that I could scrape, that I could write a script to go through and collect all the images from. Does it mean that it's the most representative data set? No. Does it mean that this should be the canon for fashion photography? Clearly not. But yeah, these are all things that can go into the discussion as well. But so yeah, this is a website I think that sells images photography, but that is quite easy to scrape. So I collected a couple thousand of images from fashion photography, from different styles, different artists, different eras, which is quite interesting, and complemented that with a data set about basically portraits. So different kinds of, as you can see, there is classicism, there is Rococo and Neo-Rococo, there is realism, Renaissance, and so on. So different kinds of styles as well, which I filtered specifically to only have images with people, so human postures in them. And I ran a couple different algorithms on them just to see what they look like. And I can show you just a couple of interesting things. The first is CLIP, and this goes back to the multimodality discussion that Antonin was just presenting. CLIP is a model that was trained on images and text at the same time. So not just on images, but on pairs, let's say, of images and text. And so what it means is that we can feed it a data set, and then we can look like for words and concepts and all things that we want to look for textually in the images. It gives interesting results. It's a way to kind of browse through, not the right scale, to browse through a corpus, basically. So here I looked for the concepts of religion and woman, and all of these little dots are images in my two data sets. And if we look at this, then we can see that for religion, for instance, this is the image that is the most religious image according to this model. It's quite religious. It's not tagged as the most woman image. Actually, that would be this one. And so we can, yeah, use this to kind of scroll. So this is the least religious image. I wonder why. I think it's not necessarily, yeah, it is quite religion neutral, it seems. Or maybe there's something that I'm missing. And then we have images that have nothing to do with these two concepts, and that's why they're in here in the corner. But it's quite interesting. There's a lot of crosses, women on crosses, which is to be expected. Quite a few naked women as well, but that I think is something that characterizes both data sets, both the fashion photography and the rest, the painting data set. So this was the first way to explore this corpus. It doesn't tell us anything unless we're looking for conceptual elements or unless we are looking for a discussion. So these are not tools that will, answer the question and in a final way, but that maybe give us a glance into these models that we're talking about and show us how they or how our data set is perceived or is categorized according to them. The next thing that I did was use the Detectron model, which can show you, what bodies look like in a density way, what different concepts are. So bicycle, child, and so on, the skeletons as well. And I also ran this on some of our images, and then they tell us person or person. And then again, you cannot see very well, but the person on the right has a lower percentage of veracity, of accuracy, according to the model, than the person on the left, which is categorized as a woman at 100% rate, which is quite high. These things then also kind of feed into perhaps the discourse of the painting. If we have someone who is behind something, of course they will be less seen by the model. Does that mean that they are less of a person? Maybe that's what the author, that's what the artist was, trying to hint at or to communicate. If this would be a lower value, so if this person was really hidden behind something, then the value would be 50%. It probably wouldn't appear. So that means that if we write something that analyzes this data, it would only perceive there as being one person. So this is also something that introduces risk, because these are percentages. They're not definitive. So we could have a result where the model says that this is not a person, and because we don't dig in to correct it and say that is actually a person, then we just lose that person into the vortex of unidentified blobs in the image. But generally, the results are quite good. I wanted to show one image, but I don't think I included it in the slide. There's a painting that shows this little blob of just randomness, and it tags it as a banana. And I think, again, in Antonin, in your presentation, you had some food, right? Or vegetables being tagged, and they were quite precise. And this thing had nothing to do with the banana. But this also goes to say that, yeah, photography can be much better understood by computer vision models than paintings, because can be like the style and the texture can be so different from what reality or realistic images actually look like. But yeah, generally the structure of bodies and of postures has evolved quite well, and so can be recognized in a high level, at a high level. Sometimes it hasn't. This is painting by Paul Tormo, where we have an angel being seen as a teddy bear, which I think is very cute. It could be in a different context, right? If this was a child's room and we see a face that looks like this, then it could be a teddy bear, but the context is absolutely different. But yeah, all of this to say that we already have some good results from these models. The accuracy is probably less than it would be for realistic photography or other kinds of visual art that are more maybe clear to the eye. But it is an interesting step in the direction of finding these genealogies. And the next step is to really formalize the matching part, which I have experimented with, gives good results, but I still could not manage to see how well it works in paintings to present to you today. Yeah, actually, starting this week, we will also be joined by a master's student in KU Leuven who will work on this project. So his work is going to be about exploring computer vision algorithms, particularly for body posture. So Quinton has just joined us this week, and he is going to be working on comparing different models. So we've talked about Detectron, about Clip, about Open Pose, about Dense Pose. There's a bunch of them, and we need to see which configurations and which settings work best for this type of images. So he will perform a comparison and also build a user-facing system, so a graphical user interface that allow us to compare these algorithms and see how well they work in a funny kind of circumstance from life. I had actually had a student working on a similar topic 2 years ago that was called Painting Networks of Images, Building a Visualization Tool for Viewing Similarity Between Artwork. This student had unfortunately stopped his master's because it was COVID and life was difficult for all of us. But I had completely forgotten about the topic until I started to work again with Maria Giulia. And I was like, I remember some literature on the topic actually, because yeah, by a chance of history, it was something I had already looked into. So that's basically what I wanted to talk about. I think there's 5 minutes left. I wanted to also discuss the limitations, and I think this painting by Pontormo is a good example of that. I call these the computationally elusive aspects of art, because there are some aspects that are maybe close enough to what is computationally possible that we think we're almost there. And if it can figure out the faces, then it can also figure out the intention of the faces, or what the faces are looking at or are thinking of, but these are elements that are still out of reach, that are still elusive, that maybe we can get to in the next few years. I hope so. But that are still slightly a bit out of reach. And so the ones that we've discussed with Maria Giulia, for instance, are the weight of bodies, let's say. So not the physical weight, but let's say the metaphorical or the figurative weight of a body feeling heavy, feeling weighing down its what on itself in an image, versus a body that is light and elevated, that can also transpire through the use of color, through the use of light. So we have all these intentions and links and connection also between the different people that are things that we still cannot really address with computer vision. Whether we will be able to in the next few months or a few years, that is something that we need to look at, and that is also something that I think we need to be aware of or mindful of the consequences or the type of applications that can be done with this type of algorithms. There's a bunch of literature about using computer vision to, I don't know, guess the gender or the sexual orientation or the race, or these are the first example in my mind, but there's a lot of misuse of these kind of systems. Whichever step that we take them, we need to accompany that with a responsible discussion, a responsible framing, and with the assurance, or the assurance that we are going with this in a way that is useful for us and that can help us get through this research, but that doesn't need to be harmful for in other applications. I promised that I would keep things short, and I see that it's already time, so I will leave it at that. I want to thank you for listening, because it's the end of the day, and also for the great discussions throughout the day. And yeah, if I think I can give you the floor back for the discussion. Thank you.